Some of the viewers have asked that I do some more on signature analysis, and rather than probe around with that SIG 101, I thought what I might do is instead go into a little bit of the history of signature analysis. And the reason that I think that could be useful is it will give people perspective about just how useful or not signature analysis is. It goes back quite a ways. In fact, it goes back to some of the early days of transistors. This unit that you see on the screen is a curve tracer that was made by Judd Williams. Later, the rights to this were acquired by Sprague, the same people that make capacitors, and it was sold as the answer to what some people referred to at the time as tube techs. That is, people who had been trained on radio and TV repair with tubes, but didn't know much about transistors. And then when transistors began to come in to consumer electronics in the late 60s and early 70s, they were really at a loss. And so a lot of manufacturers and designers, inventors, came up with various solutions to that problem, and one of them was using a signature analyzer. In this case, it's actually a transistor curve tracer to troubleshoot, and I'll show you a little of that history in a minute. The reason that I think you should have some of this, if you're new to this and have not ever heard of the idea of using this on a board to test with the power off, is it has its ups and downs. Some things work well, and other things, well, they didn't pan out as well as people thought. So what you see, by the way, this unit I bought some time ago. It does not work. I may someday, get into it and see if I can fix it, but I'm mainly just using it as a prop to where I'm going. In the November 1970 edition of Electronic Servicing magazine, this article appeared talking about quick testing of transistors, and they include a circuit that you see here for testing transistors, and then they show a variety of the patterns that these display. Notice it uses an oscilloscope, and this circuit, by the way, later was known as the Octopus Circuit. The reason I say later is actually the first reference to the octopus that I can find is in QST magazine, and I'll show you that article in a second. But those of you that might be interested in following along, electronic servicing is available on the American Radio History website as a download. And so if you go to electronic servicing and pick up the November 1970 issue, you'll find this particular article. I think it's the earliest one where service technicians were being encouraged to use this kind of trace analysis to test transistor equipment. In February 1971, Electronic Servicing published this article entitled "The Curve Tracer, Another Method of Testing Transistors." It's a two-part article, and you may notice that it features an earlier version of the transistor curve tracer by Judd Williams. In March of 1971, the second part of that article appeared, entitled "Practical Applications of Transistor Curve Tracers." And you may notice down in the left-hand corner here that once again the Judd Williams curve tracer is featured. And they also talk about an ICO model in this that could be used. As you see over here, they're showing what you might expect to see on the oscilloscope screen. In April of 1973, two articles appeared in Electronic Servicing, the first of which is this one, Curve Tracers Revisited, in which they sort of rehashed what they had been talking about in some previous articles. And once again, you see the circuit that they're talking about here. Now, this is a kind of block diagram, actually, of the Judd-Williams unit. And in that same edition, this article appeared called Using Signature Patterns to Service Solid State. And once again, the unit that they're talking about is the Judd-Williams, and you may notice this is actually a newer model. In fact, this one is a little newer than the model that I have, so we can sort of bracket when the one I have was manufactured sometime between 71 and 73. But in this article, they say that from now on, Electronic Servicing is going to be publishing signature patterns for a particular television and particular transistors in that television. And sure enough, they started publishing every month this page. This is for a Philco Ford TV, and you see a variety of patterns that they got and the transistor that it was found on and so on. So you would have thought that by this time this was a well-established practice. Well, actually it wasn't. What happened was that very soon technicians began to realize that these are very specific, and these patterns. And if you're going to use them to try to find a bad part, you really have to be using exactly the same circuit in the good unit and in the bad unit. And that's why if those of you who watched Mr. Carlson's use of this in that Sansui equipment, he was testing exactly the same circuit with exactly the same IC repeated many, many times. Some of them were leaky, some of them were not. For that application, this sort of thing works fairly well. But the generic idea that you can just take a probe and stick it in a circuit and then look at the oscilloscope and say, well, that's good or that's bad, I'm afraid it just doesn't work that way. In January 1975, and you may notice this video is sort of chronological, this article appeared in QST magazine about the Octopus Circuit. And you may notice that it basically is a lot like that circuit you saw in the very first article in Electronic Servicing, where they use a transformer and a couple of resistors. In this case, they have a potentiometer to adjust the value or the voltage, but basically it's just two probes, a couple of resistors for isolation and for current sense, and a transformer connected to an oscilloscope, and you get patterns off of the system like this, where this is a short, this is an open, that is a resistor, an inductor and a capacitor, and so on. You get the idea. In the May-June issue 2017 of QEX magazine, which is the experimenter's magazine for radio amateurs, this article appeared talking about improving the performance of your Octopus, and if you are interested in any of these, you can download everything except the QST article from the web. The QEX article, this one, is available for download, the ones that appeared in electronic servicing, which really was a later version of what used to be called PF Reporter, or Photo Fact Reporter. You can download all of those from the American Radio History, I think it is, website. At any rate, if you're interested in reading some of those, I thought that this little history might help. Now, it turns out that there was actually even one other line of these which were commercial. Let me show you those. This is a unit which was actually marketed by Tektronix back in the day. It's called the TR210. And you notice below the TR210 it says Huntron Tracker. Well, Huntron made the unit. And this is actually a predecessor called the Tracker 200 that Huntron marketed under their own name. These later became more sophisticated. This is a 2000 unit. This is out of the manual, which, by the way, you can download the Huntron manuals online as well. This was the Huntron 2000. They usually called them HU, so this would have been the HU or the Tracker 2000. And by the way, one thing you notice is it now incorporates its own display screen, so you don't need your own oscilloscope anymore. And then this is the Huntron 2800 and 2800S, the front panel out of the manual for the 2800. So what is that all about? Well, here is a portion of an early manual that Huntron published about what they called analog signature analysis, or ASA. You may notice it's very much the same thing. It's a sine wave generator, current limiting resistor, some kind of current sense, and the current is then sent to the y-axis, and the voltage is sent to the x-axis of the display. Now, what is interesting is that here is another article that was published, and you may notice that's exactly the same picture. And this article was published by, or paper was published by, Alan Lown, who, as you may know, is the principal in Selig Company today. Now, this is a fairly old article, and was back in the day when these were rather simple devices. Now, I don't know his connection to Huntron. Maybe they sold Huntron instruments. I'm not sure. By the way, I don't have any connection to Selig or to Huntron. In fact, to no commercial establishment. So all of this is just my own opinion, and hopefully not affected by the marketing hype of various companies and that sort of thing. Nor do I take free samples or money from any of these companies either. So this is sort of my take on signature analysis, and you can look for some of these articles if you would like to. I suggest that if you're thinking of using one, particularly if you're thinking of using one in some commercial or semi-commercial environment, you really ought to read some of these articles, because what you'll find is that these units are not necessarily the answer to everyone's troubleshooting needs. It doesn't mean that they're not very useful. In fact, what you will discover if you read some of these is a lot of companies, both manufacturers as well as service centers, bought and still buy these Huntron trackers to troubleshoot boards, because it's easy to teach somebody how to use it. You don't require a trained technician, and for certain applications they are great at separating good boards from bad boards. But like I've said many times, they're not the end-all. They're just a tool, and it's more a question of the skill of the user than it is the tool. So I don't plan to continue on this line of signature analysis. I know I promised some people that I would do slide rules, so I think I'm going to start doing. I've done a lot of the video for the slide rules, and I'm assembling all of that. So I think I'm going to switch back, at least for a couple of videos, to slide rules. But in the meantime, I hope that those of you that are interested in this sort of stuff will take a look at some of these articles. And in connection, even if you decide to buy one of those SIG 101s, and I understand they're now in back order, but if you do, just be aware that they can be very useful for some things and not so useful for others. So I hope you've enjoyed it. Like I say, look forward to some videos, but I promise this time I'm going to switch back to slide rules, at least for a few videos. And in the meantime, I hope you have a nice day.